Okay, 101. 101, we're learning about exponential expressions. And in exponential expressions, we're going to have the same bases. And in multiplication, we're going to add the exponents. So that looks a little fishy. We need to make sure we understand what's going on here. So I'm going to take this all off. And again, I don't have any of the answers done here. We're going to do those together. Okay. So in my first example, I have x squared times x to the third. Now let's just reach and remind us what this means. X squared means x times x. X to the third means x times x times x. Now my point is I want to be able to write the simplification for this in terms of x, is what it's called, or exponential form, okay? Which means I want my base to be x and I need my new exponent. So I want my base to be x. Now here it says in multiplication you add exponents, right? So let's think about that. If there are 2 x's here and 3 x's there, how could we rewrite that? X to the 5th. And if you look at what I've done, I've got multiplication, the dot. I take my 2 plus my 3, and I get my 5. So that's how I've simplified. Now here I have base 3, and I just want to write this in exponential form. So I keep my base the same, which is 3, and then I add my exponent, 5 plus 2, which is 7. Okay. Now here it's a little weird. I have x to the m and x to the n. So we keep my base the same and we add our exponents. So that's going to be m plus n. That is actually kind of that mathematical form of this adding or multiplying exponents. So that's kind of the general mathematical form that you might see sometimes. All right, 10 to the 15th, 10 to the 17th. We've done this in scientific notation, if you remember. This is just an extension of what we've done in scientific notation. So we keep 10, oops, my paper is going crazy. 10 times, or no, I was thinking scientific notation. I'm going to erase. Okay. 10. Okay. And then I add my exponents. 22. So 10 to the 22. Alrighty. Now here's one that is, takes a few more steps maybe. So let's remember we only do the same basis. So let's look at our a's. So we have a to the first, a to the first, and a to the 4th. So adding them together, I'm going to get a to the 6th. Then I have m to the 1st, m to the 5th, m to the 6th. So m to the 1st, m to the 5th is m to the 6th. Times m to the 6th is going to give me m to the 12th. Right? Okay, so here I have a whole bunch of x's. So I have x to the 1st. And remember, if I don't see one, I can add in a 1st. That helps me. So 2, so 1 plus 1 is 2, plus 5 is 7, plus 2 is 9. So x to the 9th, and then y to the 1st, y to the 3rd, so y to the 4th. Okay? So now we have 2 to the 3rd, times 5 to the 2nd. Okay, so I want you to see there's a problem here with this one. Okay, and it's similar to the other examples on the side. This has a base of 2. This has a base of 5. That cannot be simplified any further. Those bases are not the same. I cannot just add those exponents. Just like I can't add the exponents of x and y or a and m. I have to keep them separate. I can't simplify this anymore. It's done. Okay. All right. I'm going to show you this. Make sure that you understand. Email me any questions, and I'll be back with the last lesson. Bye-bye.